All right, gang. So here's the second video. This one, and you'll kind of find that as you do these, your problems tend to go faster. So I tend to take a lot of time just kind of showing how they're set up. But we're going to do that same process as we did before, where we read through and visualize the problem. We write before and after and kind of separate out the problem between those two things. Draw a picture for before something happened. And it's kind of like when we say before, it's like before things collide or before things push off of each other or explode. And then we draw a picture for after that happens. Then we get into the process of saying the total momentum before equals the total momentum afterwards. And this is our equation. We list out each momentum before and after. And as we're doing that, we're keeping track of direction because things going to the left and to the right do play a big role, especially in their signs. When something's not moving, we say the momentum is 0. But then we solve for our missing momentum. Before we did this problem with the car and the van, but we're going to do this problem with a hunter. It says, a hunter spots his prey off to the right. He waits patiently and does not move. When the hunter fires, the bullet has a momentum of 284 kilogram meters per second. The hunter feels a kickback after the bullet is fired. Determine the momentum of the hunter after he fires the bullet. So when we're kind of reading through this, again, you kind of want to make a picture in your head. What's actually happening? He's sitting, kind of waiting. Then he fires the bullet at whatever he needs to. And so what we're going to do is we're going to do those steps. We're going to write before. On one side, over here on the right. And we're going to write after. Again, I'm writing with my mouse, so that's okay though. And then we draw a picture. And I'm going to skip ahead and actually just kind of show you a picture, but you can probably tell which picture that I drew in this one. So we have the hunter that's waiting, and then the hunter fires the bullet. Again, your pictures, they don't have to be anything that's great. You're really just kind of sketching out what's happening. So if you're drawing stick figures, it's awesome. If your cars and vans look like shoes, kind of like mine do, that's okay too. So there's no worries about it. But we need to tell what's happening before and after, and we're separating out these two sides. Okay? So first step, right before, right after. Second step, draw your pictures. Third step is we say the total momentum on this side is equal to the total momentum on the after side. And this is setting up our equation and what it will be. But when we say total momentum, it has to be the momentum for each object. In our objects, we are talking about the momentum of the hunter. Oops, if I can spell. Hunter. And the momentum of the bullet. Over on the other side, I really have the same thing. And I'm going to keep this equal sign going as I go. Momentum of the hunter. Oop. And the momentum of the bullet. Because I'm going to be keeping track of these two things before he fires the gun and after he fires the gun. And that's what we mean by before and after. But, so they look the same. Just keep in mind, one means before, one means after. Okay? So when you're reading through the problem too, you gotta make sure that you're keeping track of where things are. Like a lot of people will look at this 284 kilogram meters per second and see it's for the bullet and they'll put it on this side. But be careful, because when we say before and after, it has to be before and after something. So before he fires the bullet, after he fires the bullet. And it says when he fires, the bullet has this momentum. This momentum is for the bullet, but it's after he fires the gun. So you have to put it on that side. This 284. And that sometimes gets a little confusing for people because they like to, a lot of people, and kind of like all of our instincts, is to kind of look up and grab numbers and kind of put them in order. But that's not the case here. So make sure you're watching that. But then it's like, well, then what is the bullet over here? When we look at the before side, we have to know what's going on. And before he fires the bullet, he waits patiently and he does not move. So if he's not moving, that means the bullet's also not moving. And that and if something's not moving, then their momentum is 0 for both of them. On this side, the momentum of the hunter, I don't actually put anything in there for the momentum of the hunter because that is what they're asking me to actually figure out. So I'm just going to leave it as momentum of the hunter. And now I have my equation. This is the hardest part, is actually getting to this point of filling out the information and setting up the equation. But going through this process is all really kind of necessary. So if you have to, or if you're kind of wondering how we got to this point and why it's set up, make sure you go back and take a look at the video and kind of rewind and you'll be good. But now that I have this set up, I'm going to solve for this momentum of the hunter and I'm going to start simplifying things. This one's pretty easy because on this side, this is equation, has the equal sign between. This side, I'm just adding these two numbers together. And 0 plus 0, I get 0, is equal to the momentum of the hunter plus 284. So I'm just going to do this. Momentum H plus 284. But to get the momentum of the hunter by itself, I have to get rid of this 284. And the only way to do that is adding, I have to subtract to undo it. And I have to do that to both sides. But it seems kind of weird to do it because there's nothing over here. And that's fine. This 284 and 284 go away. And I'm left with the momentum of the hunter and this negative 284. So my answer, momentum for the hunter. Oh boy. This is equal to negative 284. And my units, because I solved out for momentum, are these. Is this kilogram times meters per second. Now this is the answer that we get. And again, some people get kind of weirded out when they end up seeing an answer like this. You get a negative answer, but remember that when we're talking about momentum, this negative sign is really telling a direction. Because if the bullet gets fired and it's going to the right, if you've ever fired a gun or seen hunters on fire rifles, a lot of times you'll end up seeing them do this kickback. It's the from the momentum of that bullet going forward, there's a kickback on that gun and it ends up pushing that hunter backwards. And so their momentum is going to the left. If the bullet's going to the right, momentum's going to the left. But we end up with something like this. It seems like it has the same number, but keep in mind that this is momentum. This is not a speed. The bullet and the hunter will have the same momentum, 284 and negative 284. And so, but remember, momentum is a mass times a velocity. And even though they have the same momentum, one has a big mass and will have a small velocity, like the hunter. And the bullet has a really small mass, but it's going very fast. And that's kind of it. Okay? So that's how you solve out that problem. Make sure you check back if you need anything to kind of review parts of it. But that's how you do all the problems. You go through the same process before and after, and you draw pictures, and the pictures are there for you and to help organize the information. But when you organize it like this, it gets really easy. And many students say that it's really easy when they do this. Students get really frustrated when they start taking shortcuts, like they don't write this part out here, or they don't draw the picture. Many times they'll end up kind of skipping those parts and find that they put numbers in kind of incorrect spots, or they will end up marking things as the wrong sign. Like they might end up saying when it says something's going to the left, they'll end up putting a positive number down here when it should be negative. So just kind of trust the process. It works out really well. And the more that you do it, the easier it gets. And you'll find that it actually makes the process go faster. But this is kind of a messy version. Again, I'm kind of working with my mouse. If you want the clean version, it's kind of right here. That's the same thing. But feel free to contact your teacher if you have questions or things like that. All right? See you guys.